Pretty cool on the difference between distance and displacement. Oh, that was a lot of alliteration. If you have an English test coming up, that's an easy poetic device to find, and you'll get the same credit for it if you actually find a difficult poetic device. So if you see alliteration, grab it, because then you'll still get credit. And everyone's like, oh, this kid's awesome, even if you miss parallel structure, which is really hard to find. Okay? Another one that's a really good one to look for in English class is personification. That's a super easy one. I like to get that one out as often as I can when I am doing some sort of English explication of anything. I lot of personification. Another one that I don't mind using is onomatopoeia, because you can get a lot of mileage out of onomatopoeia, because it's really up to who's saying the word, isn't it? Right? Everybody says that the word, if you use the phrase, the brook was babbling past me, brook and babbling is a double-edged sword. You get the alliteration, and some people will say that babbling is onomatopoeia because the noise the brook is make sounds like the word babble. So you can get double on that with only one sentence. Yeah? Huh? I know, right? All this in brains too. So everyone is all right with distance versus displacement when we are displaying it on the digital screen. 4. Jewel, you should be jumping for joy. Connor, how cool is that? All right, Connor, seriously though, you got a math question? I can stop the alliteration at any time. Should have said what? Didn't I say display? Ah, son of a bee. It was because I had a piece of chili in between my front teeth and I was trying to get it out with my tongue, and my tongue was too busy trying to get out the piece of chili to think about display. It's still there. Oh, there it is. Got it. Yes, I ate it. I know, that's gross, but what else are you going to do, really, right? I can't spit it out. It hit Raj. Raj just made me a cool present, so I don't want to do that. All right, we all good? Everybody understand displacement and distance? Yes. When you get to your physics section in Science 10, if you haven't already done it, this will make your life much easier. You can look really smart when you can say, well, actually, Mr. Radnai, isn't that displacement instead of distance? Because displacement is a vector. And Mr. Radnai will go, who? And all the rest of the kids in the class will be like, who? And you'll be like, yeah. Unless there's other kids in the class from here. But if there's other kids in the class from here, then you can all go like, oh, slick. And you won't rat out the other person. You'll be like, oh, yeah, my friend's really smart. Right? No, you got to throw each other under the bus first chance you get. Because Radnai's going to say, wow, that's really impressive. You go, you didn't know that, Myers told you. I know that's what's actually going to happen, but I'm hoping you won't throw each other under the bus that way. How many of you have science this semester? Have you done physics yet? You're right in the middle of it? Have you done displacement and distance? No, Vicky, you have, because we did it here. All right. Okay, so what is different about this graph than the previous two we have looked at? Look closely. Oh, yeah, good idea. It's actually symmetrical. Yeah, okay. I didn't even think about that, but you're absolutely right, Mantosh. It is symmetrical, and there's a reason for that. What else? What else is different? Yeah. There's not a lot of change here, is there? Excellent. What else is different? Pardon me, Simmer? You just said a whole long sentence. You said something. Unless you're trying to make me think I'm going crazy and I didn't see your lips moving and hear your voice and hear a bunch of the right answer. Now, there's a movie like that. It's called Gaslight. The husband tries to make his wife go crazy by doing all these little things around the house and then denying that they've happened. If you've read the book by Roald Dahl, The Twits, it's similar to that. Of course you have. When Mr. Twit puts the little 1/16 of an inch thing on the cane for his wife and then he tells her she's shrinking, that's gaslighting. It's making someone go crazy by telling them stuff that isn't really true. Anyways, are you gaslighting me, Simmer? Interesting. I'll write that down. Okay, so what else is different? Instead of distance, we have speed. And isn't speed already a rate? Yeah, it is, isn't it? Now, we know that if we find this, we get the rate of change, don't we? But in this case, the dependent variable is already a rate. So I must be getting the rate of change of speed. What do we call it when we change our speed? There's a word for it. Starts with an A. Acceleration. Excellent. So a distance time graph can give us speed because the change in distance is a speed. And a speed time graph can give us acceleration because the change in speed is acceleration. Everybody cool? So now we're not talking about distance. Do you have any idea how far Alicia ran according to this graph? No. Could we figure it out? We could, but that's a physics question. We'll talk about that after we've talked about this. So, what is happening here? How many sections are there to the graph? 2, 3, 7, how many? 3 sections to the graph. I would argue there's this light green line, there's this pink line, and then there's this light blue line. Excellent. What is happening for the green line? Now, some of you will say she's going very, very fast. Because in our distance time graphs, a steep line meant she's covering a lot of distance in very little time, yeah? But that's not the case here, is it? What is she doing? Connor? She's speeding up. Is she speeding up very quickly or very slowly? Very quickly. She gets to top speed in how many seconds? 2 seconds. So let's find out. So from O to A, which was my light green line, origin to A, she speeds up. Is that a 1-level answer, a 2-level answer, a 3-level answer, or a 4-level answer? That's a 1-level answer because her speed was at 0 and now it's at 8. We can all see that, can't we? How can we refine that to make it prettier? RJ. She speeds up from 0 meters per second to 8 meters per second. Ooh, sexy. Yeah. 2, 3, or 4-level answer? 2. How can we make it a 3-level answer? What would we add to that to make it a 3-level answer? Harry?
She accelerates from 0 to 8, and while she's skating, she gains more distance.
Okay. Okay. I like it. Too much for me to write, but I like it. That could get you some more credit. RJ, you want to refine your own? There you go. 0 in 2 seconds. Now we're at a 3, right? How can I make it a 4? Yes, she's gaslighting me again. Jordy.
Well, she continued at a constant.
Oh, we're still on only the first section here, brother. How can I make it a 4-level answer? At the rate of what? How do we define rate? It's 2 pages before in your notes. What do we use to find rate? Change in what? Change in dV divided by IV. So what is our change in dV? 8. What's our change in T? 2. So she speeds up from 0 to 8 meters per second, or if I wanted a 4-level answer, she speeds up at a rate of 4 meters per second, right? So it's actually 4 meters per second squared. Everybody cool?
Why is it 4 meters per second?
Because I got 2 seconds. I got seconds there and seconds there. Everybody understand?
Yes.
Now that part of it is very physicsy, right? And I know that's not a word. I know something can't be physics-y. But I like saying words like that. And I'm the boss of me, so I'm going to do it. Okay? Shakespeare made up words. No, I am not comparing myself to Shakespeare. Because Shakespeare was a genius and I'm just me. And Shakespeare was not a lie like other people say he is. Shakespeare was the real deal. Or so I guess. Because I was not there and nor was anybody who says he wasn't. What is happening from A to B? RJ. She does not. She stays the same speed. Excellent. Can we refine that? Jordy.
She continues at a constant speed for 12 seconds.
Excellent. Can we refine that? Harry.
She stays at a constant rate of speed for 16 seconds.
16 seconds. She went from 2 to 14. Okay. So that's very similar to what Jordy said. I need one more refination? It must be. Yeah, one more refinement. Connor?
She stays at a constant rate of 8 meters per second for 12 seconds.
There you go. Does everybody see how we went from a 1 to a 4? Everybody? So I'm not going to write down 1, 2, and 3 because what do we seek here? What are we trying to get? We want the A's, right? We want the 4s. We want the 7s. Whatever the scale is. Go back to grade 3. We want the exceeds expectations, right? We aren't happy with a participation ribbon, are we? Excellent. So, she maintains a constant, you could even say top speed, maintains a top speed of 8 meters per second for 12 seconds. And you may not think it, but that's pretty darn fast. As a matter of fact, it is almost 25 kilometers an hour, which is pretty fast running. It borders on world-class running speed. And finally, in light blue, Jules' choice, B to C, what happened? Again, what's the one-level answer? We're going to talk about the 1, 2, 3s. We're going to only write the 4. What's the one-level answer? Slows down. Right? Way to go. Good job, everyone. What's the 2-level answer? How can you refine that? Give me more information. Mantaj. Her speed decreases for 2 seconds. Great. How can we make it better? Harry. Okay.
Her speed decreases at a rate of 4 meters per second squared.
Decreases at a rate of 4? So wouldn't that be... That's a good 3 answer. How can I make that a 4? What in math shows me decrease? Say it loud, Shitu. Don't gaslight me. Negative 4 meters per second squared. Right? Everybody cool? Now, even that, I would still probably only give you 3.5 because something happened right there that we haven't talked about. What happened at 14 seconds? Why would she start to slow down? She finished the race. Now, some kid always says there, well, if she stopped, why didn't it go straight down? Did she run into a wall? No. That would make the Olympics very interesting if the finish tape was a brick wall. It would be like, who gets the world record this time? Well, no, because if Usain Bolt hit the wall at full speed, there would be no concussion. He'd be dead. Because that dude is moving at 7 meters is how long he takes, just a little over 9.7. I think it's 9.79 per 100 meters. So 9.79. He is moving 0.097 times. Dude is running at 35 kilometers an hour. Yeah, that's fast. Next time you're in a school zone, look at a car driving by at 30. And be aware that Usain Bolt could not run in a school zone without getting a speeding ticket. What? That's true. You'd only get one shot at it. And of course, even then, technically, would the line be straight vertical? No, why not? What does a straight vertical line tell me about time? It's a stopped. Does time stop? No. Now we can argue quantum physics, that time is a construct, and it doesn't really exist, and it's subjective, and it changes, and it's not always the same, and blah, 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 blah. But let's be honest here. Time is a straight line going away from us. Right? I mean, for our perception, that's what time is. So let's just leave it that way. All right? Now, my wife and I were just talking about this morning because we are old. I am going to turn 45 in 2020. My wife is going to turn 43. And she said this morning, man, I'm turning 43 in 2020. I was like, yeah. And she's like, I don't care about getting old. I'm like, I don't really either. And then she says, but then I start doing some math. And it was 35 years ago, she says, when the thing we were talking about before happened. When you do math that way, it seems weird. Even for you people. It's been 13 years since you had to wear a diaper. That's a long time. I hope it's been 13 years. Why are they picking on you, Jewel? All right, so B to C, race ends at what? At 12. No, it was 14 seconds. And she slows at a rate of -4 meters per second squared. Cool? Now, all regular people call that deceleration. Your physics teachers will not agree. Your physics teachers will get mad at you if you say deceleration. They will want you to say negative acceleration. Okay? Now, you're great. Who teaches you guys grade 10? Mr. Easton? Mr. Radnai? Yeah. Now, I don't know how much physics Mr. Easton does, but Mr. Radnai is more of a chem guy. He might be okay with saying deceleration. But when you get to physics 11 and you have Mr. Morrison, don't say deceleration. I'm telling you, don't. It's also technically not true, right? If you get right down to it. All right, is everybody good? Okay, this is my favorite page of this unit. Because I am not doing this for you. All of you on the left of this page attempt to draw those 4 graphs. Please do it on the left in case you screw up. And believe me, I have a lot of fun with this page. Go. All right. So let's do the first one. Because, let's have some fun here. Draw a height versus time. Well, there's my graph. Where's time? Yeah, why? Time is the independent variable, and usually the class. Oh my God, that sucks. That is awful. I hate it. But anyways, usually time is on the x-axis. Is it always? Let me give you an example. What if, now I'll do it later. So over here is height, yes? Now, here's where we get to have some fun. Where does the first dot go on my graph? I'm going to make a tidier graph. Look what I'm going to do. I'm going to make a... Yeah, buddy. Okay. Where does my first dot go? And this is probably going to be my first chance to have fun today. Where does it go? Now everybody's like, oh, I don't know, because if he says he's going to have fun, then... First dot goes right there? How many people agree that the first dot goes right there? That would be a really wicked hard swing to swing on, because that says the swing is at 0 height. So I'm going to sit on my swing that's right on the ground. Dad, can you push me? Dad! Oh, I know, I'm not pumping hard enough. I'm not going anywhere. So, that's my first one I get to have fun. Sarav. What? All right. So, well, it all depends on how you measure it, yes? If Sarav was measuring in meters, you would not get on a swing that was 3 meters off the ground. That would be a difficult swing again. As a matter of fact, in today's North American society, not one of you would get to play on that swing because there's a possibility of danger. Okay, so we got to start a little off the ground. Now, what will happen to my swing? I'm sitting in my swing now. How do I make it go? I got to call my dad over to push me, right? Now, I go to playgrounds every so often, and I see kids way too old to be being pushed, getting pushed. Now, my little kids, as soon as they learned that you could make yourself go, they never got another push. So, the way to make yourself go is, of course, what? You stand up, right? What happened to the swing? The swing stayed there? I'm going to swing now. Oh, crap. That's not going to work. What happened to the swing? It goes a very tiny bit up, yes? Now, when I lift my feet, what happens to the swing? It goes back down. Will it ever go below this line? Of course not. If I know what I am doing, what will the next lump be? A little bit higher. Will it be a steeper slope or a shallower slope? Slightly steeper, because why? I'm going higher. That means I'll go further up the height. Why will the slope get steeper? Because I'm going faster. Will it ever go vertical? No. Now, some kid always on the left, because I said on the left, so I'm going to draw it over on the right where all the kids did draw it. Some kid always draws this. Because that's the way a swing goes. I'm going to hope that in this room ain't nobody drawing that. Because you got to swing mighty fast to go back in time. Right? Ain't none of you drawing that, are there? I see 3 heads go, no, not me. And then you can always tell the kids that started drawing that and then realized because they look around. And then the kids that actually got it right just like, oh yeah, I had it all along.
I didn't have it right.
And of course, the height must go up and down. Yes? No, RJ, no matter what your grade 6 cousin said to you when you were in grade 3, you cannot swing the swing all the way around the bar. It is physically impossible unless the swing is on bars, not chains. That's why the big loop-de-loop thing at Cultus Lake Amusement Park has a bar. Because if it was on chains, it wouldn't be able to get all the way around. As soon as you got up to the top, you would all fall to your death. There is a kid in my regular grade 10 class who insists that he has swung around the bar on chains. I will not say who the kid is. All right. Okay. Class. It only works because we're joking about it today. Oh yeah, okay. I'll try it in December and see what happens. All right. Distance time graph for completing a 400-meter race. Will my line ever come back to the x-axis?
No.
Why not?
Because it doesn't end.
No. The race ends at 400 meters, Jewel. You don't just run forever. You're not Forrest Gump. Why? No. Vicky said it.
That's displacement.
That would be displacement. And what is this? What do we got today? Barf.
A T circle. Which one's that?
Forever nuts, which sounds funny. And Buddha's blend. Oh, I'm going with the Buddha. Don't auditorially shame my cousin.
Yeah, right away. You were I never said anything.
We could probably
I just
go
was-
to
I didn't
Babies.
I didn't confront him.
So that would be displacement, yes? And do I want a displacement graph? Somebody set a timer for 3 minutes.
One.
If you count to 300, or if you count to 180, I will go 8. All right. So, what's it going to look like? It can't go back down to the ground. So what's it going to look like? It's just going to go up. When's it going to end up here? 400. When's it going to end on time? Well, that depends. Are you walking around the track? I'm going to say it's going to end at 90 seconds because that's a really slow lap around the track. Even I can beat 90 seconds around the track. So, is that the appropriate graph for someone completing a race?
No.
Why not?
Because they're back. What if someone
Let's talk. We are talking right now. There's no right or wrong. Caden, why is that?
Because you slow down when you get tired.
You probably aren't going to maintain a constant speed, are you? Right?
You start out faster and then you reach your
Okay. Does anybody else? Yes. No, Alicia goes up to a constant speed and maintained it. Does anybody have something to add to Caden's analysis? Harry?
So what if then you're Olympic athlete? When do you just like keep it stay at constant speed and training for it? I mean, you keep racing, you don't go low. You keep
Okay. I hear what you're saying. We'll talk about that in a moment. Vicky?
Isn't it though that we're measuring distance and it wouldn't change if he's running the race, he'd always be moving forward?
Yes,
Slow down.
I agree. But isn't there times in a race when you want to cover more distance in less time? When? At the end and at the beginning. You have to accelerate from nothing, right, to get up to a speed, And then you should have a finishing kick to beat everybody out at the end, yes?
Yes.
Okay, Connor.
There should also go higher than 400 because it takes time to stop.
You could certainly make that argument as well. Yes, you could. If we were tracking the distance traveled by the runner, yes. If we were only tracking them over the course of the race, it could still stop at 400. But excellent point. All right, so let's refine this. How will it start? Shallow or steep? Steep, because you want to get up to speed fast, right? So we get up to speed fast. Then what happens? I settle into a pace, right? Would that be flat? No, of course it wouldn't be flat, because flat means I'm not moving on a distance time graph, doesn't it? So what would it be? Still up. Ah, thank you. And then, what happens at the very, very, very end? I'm going to have another big speed up, yeah? Everybody cool? Cool in the gang? You don't even know who Cool in the Gang is.
I don't.
You know the song? Celebrate good times, come on. You know that song? Do, 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 do. You know that song? Yeah, that's Cool in the Gang. They're a great band. And also, in one of my favorite movies of all time, one of the characters says, Cool in the Gang, when he wants to say that something's cool. And so since that movie came out in 1994, I've been saying that. Sometimes I even send texts to my friends if I need to say that something is okay. I send them a picture of Cool in the Gang. So then they look at it and they're like, what? And then they text me back like 3 minutes later, that's Cool in the Gang, isn't it? I say, yeah. And they're like, how long have you been waiting to use that? I've been using it for years. Then sometimes I text young people who have no idea who Cool in the Gang are, and they're like, why are you sending me this picture of all these black guys? Because they're all black people in the band. And they don't know who it is. Then I say, haven't you seen Pulp Fiction? And they say, what? Because that movie came out in 1994. Pulp Fiction is one of my favorite movies because Pulp Fiction is one of the greatest movies ever made. What?
My dad said that everyone knows age, but know what Krakatoa.
Everyone what?
His age would know what Krakatoa is from.
Yeah.
Do you not say that?
Krakatoa is volcano. Yeah. And it erupted in, I can't remember when, but it was a big deal. All right. What's different about number 6, 7? It has to come back down because it's displacement, right? So, will I speed up the same way? Probably. I'll start speeding up. And then what? I'll slow down till when? When do I start coming back home? So when do I start coming back home? Halfway. What's half of 400? So this is going to be 200 now. I'm going to have a peak. And then what? I'm going to come home, yeah? Am I going to keep this same slope? What, Simmer? You're gaslighting me again. I know, right? The only thing that makes me angry is when you people don't give answers. My grade 11 class, I was trying to get them to count today. And they wouldn't. Right? We were doing a graph, and I said, okay, here I am at this point, 2, 6. This point over here is one more. What's it? Crickets, not a word. I almost had to stop class and go to YouTube and get the count from Sesame Street. One sheep, to remind them how to count. So nothing bothers us I'm going to take it back. Nothing bothers teachers more than the sounds of crickets. You are better to be wrong. So, what happens here? I turn back home. What will the line look like? It'll go downwards. Will it go down like that? No. Will it go down like this? No. How will it go? The same. Because I want the same speed, but I'm heading home. Until here, what will happen? it will speed up significantly, yes? So, will it go like that? Because that's a fast line. Only if I can run faster than the speed of light. Or I have a 1985 DeLorean powered by plutonium and a flux capacitor that's going 88 miles an hour. Oh, really? That's freaking wicked. Maybe I should be Doc Brown. I got gray hair. You'll see tomorrow. And finally, this one is going to be different for everyone, yeah? Now, I would like to ask, why are all of my graphs only showing positive y's and positive x's? We aren't going backwards in time. There's no such thing as negative time. And there's no such thing as negative distance, is there? Right. So, for me, I live 32 kilometers from school. So what will be on this side? Distance from 0 to what?
32.
I would probably go to 35, so I'm a little past, yeah? And it takes me 25 minutes from my door to school. So what would be down here? Time in minutes. And I'd probably go 5, 10, 15, 20, 25. Everybody cool?
Cool.
Now I drive to school, right? So when I leave my house, it takes me 8 minutes to get to the highway. So when I sit down in my car, where's the dot start? 0, 0, because I'm 0 kilometers from home and the time hasn't started yet. For 8 minutes, I am driving through Chilliwack. Do I drive fast or slow? Slow, 50 kilometers an hour. Is it going to be constant in reality? No, why? Stop signs, traffic lights, idiot people walking across the street in front of me, a raccoon, a possum. Although I often want to run over possums, I never do. I hate possums so much. One time, one was even on my back deck. Oh, possums are the grossest animals in the world. I hate them so much. Anyways, 8 minutes, I'm going to go about 50 kilometers an hour, yeah? Right? Now, you're smart young people. Let's say it takes me 10 minutes. At 50 kilometers per hour, how far will I go in 10 minutes? What do I have to do to 50 to find out how far I will go in 10 minutes? Divide by 6, which is about 8 and a bit, yeah? So, I go from, in 10 minutes, I go up to 8K. So 5, 10, 15, 20, 25. Damn it. Damn it! Shut up, you guys. This isn't easy. 30, 35. Jeez. So in 10 minutes, I go up to about 8K. Constant line. What happens then? You guys have all driven from Chilliwack to here or here to Chilliwack. What do I do when you get out of the city? What do you hit? Hit the highway. So what happens to your speed? Goes up to about 110, right? Which is pretty much double, yeah? So I need to double this slope, right? So I'm going to double this slope for how long? I'm 15 plus 10. Yeah, about that. So for 15 minutes to about 25, I'm going to be double that slope, right? And then what happens when I turn off the highway? I go back down to this slope, yeah? 50 kilometers an hour. And then I arrive at school. Everybody cool? That's distance, position, time as I travel to school. What if I made this travel to and from? What would happen? It would reverse. Would it be necessarily exactly the same? No. Why? What can happen in the afternoon? There might be traffic. There might be road work. There might be all kinds of things. Everybody understand? All right. Your job today, ladies and germs, 101 to 103. It looks like a lot of work, but please notice how much space is used up with questions and pictures, right? Now, if you are going to pick and choose, which is always your option, you are always allowed to pick and choose what you do. Make sure you can do the last couple, because they're always the hardest. Okay? All right. You got 10 minutes now. You would have had more, but we went over the test at the beginning. You got 10 minutes now, and you're doing the rest tonight. I don't want to give you homework on Halloween, because even though you're in the 10th grade, if you're like me in the 10th grade, that was the last year I actually went out with a costume and got candy. In grade 11, I took my sister, but that doesn't really count because she was in grade 3. So I wasn't trick-or-treating. I didn't wear a costume, but I was out on the streets. And then in grade 12, I did nothing. I sat at home. Well, you get back to wearing costumes. I started wearing costumes again. So I do not wish to give you homework on Halloween night. So, I know, right? Because it's Halloween! To quote Brooklyn Nine-Nine.